Good evening, sir. We are from Group A2. I'm Jake. Let's start the demonstration with the outcome one, which is the junction first. There are three main features we implemented in our design in junction, which are TSP for ART, emergency vehicle preemption, and solving the traffic congestion by adaptive traffic control. So let me cover the solving traffic congestion first. This feature is achieving by using the millimeter wave radar sensor installed on the elevated poles at four sides of the road. So the radar sensor is worked with algorithm SC and PNN to identify the congestion levels for each road. So once the congestion level is obtained, it comes to our software simulation part. These inputs represent the traffic congestion levels for each lane, and the constant blocks with 1 shows the corresponding level for the lane. If all are 0, it means the lane is empty and served for only 3 seconds, otherwise it's served 15 seconds for low, 30 seconds for medium, and 45 seconds for high congestion level. So in our simulation, this input data will be preset first for better observation when running the simulation. Let me demonstrate the normal traffic condition first, which all the input will be set at low congestion for 1111 for lane ABCD and corresponding to 15 seconds for each lane. When I run it, for lane A, this is the traffic light for lane A, which is for the straight vision. It will serve for 15 seconds. And once it reaches 15 seconds, it will turn to amber light and then red. And another 3 seconds, it will change to the next lane. Then it changed to lane C. And lastly is the lane D. And this is the normal traffic condition where each lane will serve for only 15 seconds and without any changes. In another scenario, I set lane A to low congestion level, lane B to medium congestion level, lane C to high congestion level, and lane D is an empty lane. And let's try it out. So when I run it, the first one is lane A is low congestion level, so it will run for 15 seconds for the green light. After 15 seconds, it changed to the traffic light for lane B, which is medium congestion level, serve for 30 seconds. So after 30 seconds, it will turn to red and change to lane C, which is with high congestion level, serve for 45 seconds. So after 45 seconds, it changed to a lane D, which is empty lane, so it only light for 3 seconds and turn to red. And this scenario shows how the traffic congestion can be solved by the adaptive time control. And that's all for traffic congestion solving.
For feature 1, TSP for ART, and feature 2, emergency vehicle preemption, the OBU installed on the vehicle will send transit requests to RSU at 180 meters before arrival. So in the simulation, the transit request or the cancel message is simulated by clicking these buttons. For ART, we just need to click once. And we have designed a step machine to automatically cancel the request after crossing. But for emergency vehicle, we need to manually cancel the request like this, because in real life, the emergency vehicle may not arrive and finish crossing at the expected time. It may move slowly within the traffic. So during the simulation, you can play around with it and observe the traffic signal change. For your information, let's say there are more than one ambulance request for crossing. For the current solution developed, it can't remember the sequence of the requests. And in fact, it will just check it by lane A, B, C, then lane D. The transit request will consist of information, including the current lane where the vehicle is at, which is stated in these buttons, and also vehicle speed. So this is the ART speed, and this is the emergency vehicle speed. And these values has to be preset before you run the simulation, and it is limited to this range. Now current phase is lane B green, so if ART request is suddenly received, you should expect the current phase to terminate with the maximum allowed green interval, and you can see the warning flashlight, and every lane is hold in red. And after ART arrive and finish crossing, the traffic cycle will resume. Now current phase is lane A green. If suddenly emergency vehicle request is received, then you shall expect the current time to be extended, and let's wait for a while. And you can see here now the emergency vehicles already arrived and it get its green light. So after we cancel the request, you can see that the phase will terminate immediately to reduce the waiting effect. Now current phase is lane A. If suddenly emergency vehicle is coming from lane B, and this is a special case because the next phase of lane A is lane B. So after the lane A terminates earlier and green light granted, and this is a special case. So after the emergency vehicle cancel its request, the green light granted will not terminate immediately. Now current phase is lane C. If suddenly an emergency vehicle request is received from lane A, we should expect the phase to terminate earlier, and green light will be granted for lane A. And also, you may notice a small delay between the LED indicating the vehicle, the emergency vehicle arrival, and the green light granted. It may due to the simulation time, and after finish crossing, the phase will terminate immediately, and the traffic cycle will resume based on the previous memory. So now it will back to lane D. Now current phase is lane A. So if the request is received during hold interval, either amber or red, so if one more phase is allowed, then it will be inserted. So lane C is inserted, then followed by the green light will be then granted for lane B.
Station DM04 is located between the two lanes of the road, and several sensors are installed as part of this adaptive pedestrian crossing system. There are three main features inside this system, which including the smart traffic light transition, which act as the normal operation, and two smart features, which are the extension based on IP camera head count, and secondly, smart car extension for elderly and person with disability. In the left-hand side traffic, microswitch was physically implemented to control the input physically for the pedestrian button input, while another button is available in simulating software. Either one of the buttons is pressed, it will trigger the pedestrian button input and generate a value of 1. A PIR input is simulated using a phototransistor paired with an IR LED. When the distance between the phototransistor and IR LED become very close to each other, the system detects presence of vehicle and set car input to be 1. The output of both car lane traffic lights are displayed using two LED traffic light modules, and the same output are also shown in the simulating software by using the lamp display board. Other inputs are controlled through the simulating, such as the pedestrian head count obtained from the IP camera, which is adjusted using a slider, and the code reader activation, which is triggered using a switch. On the right-hand side traffic system, all components are identical to the left-hand side, except that the PIR sensor using a toggle switch, and both pedestrian buttons are represented by on-screen button. The pedestrian traffic light transition for both sides are also displayed on the 2D diagram. In normal operation, which included smart traffic transition, the default green interval is set to 15 seconds. At the no vehicle situation, which means that located the photo transistor and IR LED further apart and the pedestrian button is pressed. Then, the pedestrian traffic light turns into green after car lane traffic light undergo a 3-second of amber to red transition. The display block located next to pedestrian light will show the countdown starting from 15 seconds. Consequently, when the green interval ends, the car traffic light will turn back to green. On the other hand, the right-hand side traffic also operates with the same function. It allows pedestrians to cross the road safely without waiting when there is no vehicle. During the last 8 seconds, the pedestrian green light will begin flashing to warn the users. In the scenario where a vehicle is detected after pressing the pedestrian push button, the pedestrian must wait for 15 seconds before the pedestrian traffic light turns green. This setting is implemented to prevent instant switching and reduce the risk of accidents. One of the smart features is green extension based on IP camera head count. It helps to reduce crowded situations on pedestrian crossing. When the number of pedestrians obtained by IP camera using YOLO algorithm is 10 and above, it had been further extended to 25 seconds. Countdown system is proceed to this value. Whereas for 20 people and above, the green interval becomes 35 seconds. Therefore, the countdown display will counting start with the value of 35. Lastly, for 30 people and above, the green interval will increase to the maximum of 45 seconds. It is also shown in the countdown display. The second feature is Smart Card extension for elderly and PWD. Different activation timing result in different outcomes. When elderly and person with disability tap their card during the red phase of pedestrian traffic light, 10 seconds of extra time is added to the upcoming green phase. The value increased from 15 seconds of default to 25 seconds. At green phase, it directly increased the current green. During phasing green, the activation of corridor will not give any extension for the current green interval. However, when I start the next cycle of traffic light, the smart card extension is successfully added. Whereas the extension can be added for every situation except when the head count is 30 and above. It already reached the maximum, therefore no further extension is added.